Welcome, everybody. Good morning, good afternoon, good evening, wherever you are on the globe. Thank you so much for joining us. This is our first ClimateSCOpe, organized by the Space for Climate Observatory in collaboration with the UNOOSA for Outer Space Affairs. Let's wait one more minute for more people to join us, and then we'll start shortly after that. Thank you. Okay, I think we can start. So thank you so much for joining us today. This is our first ClimateSCOpe. The thematic is aligned on the international agenda. So we choose monitoring our oceans for the first thematic of our first webinar. I would like to point out that this session is being recorded, and the recording will be available on the YouTube webpage of the Space for Climate Observatory shortly after this webinar. And we have put a little QR code here that you can scan, already ready to give us our feedback at the end of the session. This is, again, our first ClimateSCOpe, so your feedback would be much more appreciated to help us to integrate your feedback for the next session that we will have hopefully in October this year. Thank you so much. And without further ado, we're going to start with some opening remarks from Laurent Charon, who is the head of the Space Application Section at the United Nations Office for Outer Space Affairs. Laurent, please, the floor is yours for your opening remarks. Thank you.
Thank you very much, Claire. I hope everybody hears me well. Welcome from our side, on behalf of the UN Office for Outer Space Affairs. I would like to greet you all for today's webinar. As you know, our office is an active supporter of the Space for Climate Observatory. I understand this is the first edition of the ClimateSCOpe within the initiative. And this is also the result of a cooperation between the SCO and UNOOSA. We are proud, of course, to support the Space for Climate Observatory since its creation, and in scaling up the voice and the impact of the initiative on the international stage. And I hope that we did our small part in making that happen. The SCO, as you know, brings together and coordinates efforts to promote the use of Earth observation for monitoring, mitigating, and adapting to climate change, especially at local levels. I understand you'll hear more from the observatory in a minute, but until today we have 54 signatories and a portfolio of more than 124 projects that got awarded the SCO label. These ClimateSCOpe series were created to align with the international agendas, and it's no surprise, let's put it that way, that the first thematic, the first topic for today's first such webinar is related to the ocean, and that's because just a few weeks ago we were all in Nice, hosted by France for the third UN Oceans Conference, and our office UNOOSA actively participated in UNOC, and we also contributed and supported the launch of the Space for Oceans initiative. in collaboration with the French space agency CNES. About 28 entities so far have signed this initiative from both the space and the marine communities. So today you will hear a selection of three Space for Climate Observatory projects, one on monitoring benthic habitats from Norway, one on observing vulnerable coastal zones affected by climate change from colleagues in France, and then one on tracking coastal ecosystems and blue carbon from the UK and Sweden. So without any further taking your time, I would hand over back to Anne-Claire to continue with the presentation. And thank you again for joining us today. I see good turnout and looking forward to more of these webinars in the future. So on behalf of UNOOSA, I wish you well and thanks again for joining. Thank you.
Thank you so much, Laurent, for your opening remarks. Now I would like to hand over the floor to Frédéric Bretard, who is the head of the Space for Climate Observatory.
Hello, everyone. Thank you very much for attending this first ClimateSCOpe. I will not come back to the very nice introduction that Laurent made. I think we have one or two slides. Right, so then I can go a little bit. Thank you. And the other one, please. The Space for Climate Observatory, in 2 words, it's an international alliance developing Earth observation-based services for local decision maker and users to adapt to climate change. This is the motto we will tackle today. It is an international charter, very dynamic. And it is also a portfolio of projects. So today there are 123 projects and around 51 countries and a big network of more than 500 partners. We are dealing with various thematics, all related to climate change, atmosphere, air pollution, agriculture, biodiversity, etc. So today we will focus on 3 of them, and I'm very happy that you were able to join this meeting. Thank you. Yeah, sorry. Maybe just a last snapshot over our project, our portfolio. They are located everywhere on Earth. Most of them, I mean, the majority today is on Europe, okay? But you can see that many of them are located in Africa, South America, and China and Southeast Asia. So I invite you to visit our website and to know more about, to add additional information on all of these projects. I don't know if we have this slide related to the call for proposals. I'm not sure. Just for you to know that all these projects have entered into this big portfolio through a call for projects. Every year, we are opening this call from 1st of September to mid-November, and we're getting accreditations to these projects. So next year, it will be the same process. So I really invite you to contact us so to know the exact process. Thank you.
Many thanks, Frédéric, for this presentation of the Space for Climate Observatory. And of course, I would like to invite anyone who have more questions about the scope to contact the scope secretariat directly, and there will be an email address on our last slide at the end of the webinar. And without further ado, I would like to invite Nicolas Picot, head of the Oceanography and Hydrology Department at the French Space Agency, CNES, to present the SWOT mission.
Yes, thank you. I hope you hear me well.
Perfectly well, thanks.
Thank you. So I will be pleased to share today some results from the SWOT program over various surfaces. This is on behalf of the SWOT project on the science team. And as you may know, SWOT was launched more than 2 years ago and is a partnership between NASA, CNES, and the Canadian and UK space as well. So next slide, please. So the main goal of the SWOT is to provide a global inventory of the freshwaters and ocean circulations worldwide, with a mission life duration of about 4 years, and we have already spent 2.5 years in orbit. So SWOT goals is to make the first global survey of Earth's surface water for both the ocean on the left-hand side and the hydrologic part on the right-hand side. Over the oceans, we measure the heights, the wind, and the waves with a precision increase of an order of magnitude of 10 times better than the current flying altimeters, and we provide the 2D images with a massive coverage, which is very new for these surfaces. For the hydrology part, this is the same. We intend to provide a global inventory of lakes, reservoirs, rivers, and volume changes over various surfaces. We have not to forget the secondary science objectives, because SWOT is measuring all times. It's a radar missions, no cloud sensitive, so it provides data over the whole Earth up to about 78 degrees north and south. And so it covers polar oceans, some land ice, and obviously the coastal domain, and we have different applications ongoing. Next slide. My focus for today will be over inland waters on the coastal application, and I will not talk about the ocean surfaces. So SWOT program in a nutshell, it was a continued cooperation between NASA and CNES over 40 years, starting with TOPEX in the late 80s. It's satellite altimetry, surface water, wind and waves. We have hundreds of published papers every year as part of the climate change on other applications. It has many operational usage, mostly over the oceans today, for the hurricane forecast, marine safety, and coastal flooding. SWOT is clearly a breakthrough in satellite altimetry that you will be shown in the next slides regarding the early results. In terms of timeline, it takes over 20 years to have this kind of missions launched on in operations. And we have a successful launch in December 2022. In summer 2023, it was a validation phase with the release of the beta product. And since 1 year, it's the end of the validation phase, and we have released the first validated products. Next slide. It was quite complex in terms of development because we have to face several challenges. It's a very demanding mission in terms of accuracy and precision. We'd like to have an orbit determination with an accuracy better than 1 centimeter at 900 kilometers away. In terms of pointing accuracy, we are dealing with a micrometer precision on a 10-meter mast, so 0.0001 degrees in terms of precision. And we have to face also the COVID situations. So it's a quite complex, and it's working so well that we are very happy with the results that we see today. Next one. Just start with inland waters. Next one. Let's start with the first image over Toulouse, where we were very, I would say, surprised by the number of very tiny inland water surfaces that SWOT was able to measure. SWOT mission expectation was to measure rivers with width of 100 meters. On this map, for the one that knows Toulouse and the surrounding area, we observe very small rivers or canals that are as large as 10 meters only. So you can see that we have a very large capacity in terms of observation with SWOT worldwide observed on this map. So we see all rivers and all surrounding lakes or reservoirs around Toulouse. Next one. The first example for the Tibetan Plateau, the figures compare directly what is currently available with the currently flying Nadir or LIDAR altimeters coming from ICESat, ICESat-2, or the Sentinel-3 satellites. And the figures highlight the number of lakes that can be observed by the different missions as a function of the size. As you can see, most of the satellites can track up to, I would say, 200 or 300 lakes only, while we have roughly 100,000 lakes to observe over this area. And SWOT will be able to fill the gaps over these very important surfaces because it's changing a lot in relation to the climate change. Next one. Further to the north, in the Alaska, this is also a view of the SWOT capability where you observe the rivers on the surrounding lakes and reservoirs. And with SWOT, we will be able to observe how they are connected, how they are playing the role, and what is the contribution from lakes to the actual rivers discharge. And what is the seasonal changes over those surfaces that are very difficult to track remotely. Next one. Coming back to France, over the Rhine rivers, we have a first comparison in terms of accuracy between in-situ data provided by various groups in EDF, Vortex or Vigicrew, in the red dots, on the green dots, on the SWOT actual observations. And you can see that we observe very well the canals over Rhine rivers on the surrounding rivers. And we have an accuracy which is better than the expectation of the order of 5 to 7 centimeters in this area, which opens the room for several applications, even to manage the different usage of the river's discharge to generate electric power over this site. Next one. Regarding floods, some floods occurred 1 year ago north of France, and we were quite surprised to see the extent of those kind of, I would say, SWOT inundation maps. On January the 3rd, it was in purple. On January the 8th, it was in red. And if you look closely at the image, you observe that sometimes we have some red dots surrounding by purple dots. So why we have this kind of situation over this area? Next one. It's just because we have some lockers, some small lockers that are protected by dikes. On the dikes have allowed to protect the field, and they were filled up between January 4th and 5th as a function of river water level, which exceeded 3 meters in this area. And this is quite the first time that with this kind of mission, we are able to observe both the extent and the elevation over very large surfaces. Next one. Let's go back to the north again. For the lake ice, SWOT has shown a very large potential for observing lakes under thin and low ice covers. And this kind of observation is again a breakthrough in terms of observations, and it has been very important for the Canadian people in terms of capacity building to monitor where the ice is located over those areas. Next one. But SWOT is a global inventory. On this map, you observe the difference between the blue ones, the natural lakes, and the red ones, the reservoir, in terms of variations. And as you can see, obviously, the changes in natural lakes and reservoirs are very constructed, and we have been able to observe over 200, roughly over 150,000 reservoirs, including controlled lakes identified with the database called GeoDAR. Next one. And if you zoom in some area, for example, over India, we observe a strong decrease of the reservoir water level as a function of irrigation use. Next one. Next one. On this one, we have only, I would say, an animation of the SWOT observation of South Asia. And you observe the strong variations or evolutions from time to time over this 4 months period regarding, again, the natural lakes and the reservoir. And this is, again, the first time that we are able to capture the usage of the freshwaters made by human to support some needs in terms of agriculture or industry. Next one. We will skip that one. Next one. So if we go to inland beyond waters, next one. Everything that is bright in the SWOT image for the radar can be processed, and we have demonstrated the capability to observe the floodplain DM on the floodplain elevations. So it's quite complex in terms of processing, because the water detection used by default, we keep only waters, but with specific algorithm, we are able to observe the terrain and to determine, like a DM, digital elevation models of the actual surfaces surrounding the rivers. Next one. Next one. And this is what has been done by several colleagues in France, in the Bay d'Evey, in Normandy, where we have actual in-situ data provided by IGN LiDAR references and some drone overflights. Next one. On the SWOT DM, when the tides were low, has been computed directly, and this is the elevation in meters between -2 and 5 meters. Next one. On comparing the two, we have a very good overflight or quality between the drone campaign performed in August 23 with the SWOT measurements performed over this surrounding area. This is very promising in terms of techniques to demonstrate and to monitor the position of the sandbanks that are close to the coast. Next one. Just a word regarding coastal altimetry. This is a map comparing SWOT topography with the surrounding terrain in Brittany. And we have a first comparison with the tide gauges with a root mean square of the order of 9 centimeters for SWOT, while it was 16 centimeters for Cryosat 2, which demonstrates the high quality of SWOT over these complex surfaces. Next one. And by comparing with the Sentinel-1 water line elevation, we have very good agreement on the left-hand side, on the right-hand side. But Sentinel-1 is not providing the topography. This is only the case with SWOT. On my last slide will be that one. With SWOT, we will be able to observe the coast and to see the interaction between coastal geomorphology, coastal complexity, the river discharge, and what is coming from the oceans. Next one. And I will stop my presentation with this slide, and I thank you for your attention.
Thank you very much, Nicolas, for this very insightful presentation. And I think that was the perfect introduction to our SCOPE project. So I think I will hand over now the floor to my colleague Alexia for the presentation of our 3 selected SCOPE projects for today.
Thank you, Anne-Claire, and thank you very much, Nicolas, for your presentation. It was very interesting, and it gives some insights about the potential applications for the SWOT mission. So now, as Anne-Claire said, we are very thrilled to present 3 projects that have been accredited under the SCOPE. So the first one is from Norway, supported by UNOOSA, the Norwegian Space Agency. It's HabHB. We then will have the Littosat project from France that is supported by CNES, the French Space Agency. And then we'll finish with the SwedCoast Blue Carb project from Sweden that is supported by UKSA and SNSA from Sweden. If you do have some questions, please don't hesitate to send them in the chat, and we'll have 5 minutes after each presentation so that they can answer to your questions if you may have some. So to begin, as I mentioned, we will welcome Lars Johan Notsville, who is research scientist at the Institute of Marine Research in Bergen in Norway. So just in a few words, HabHB is a project that aims to improve the detection and warming of high biomass phytoplankton blooms in the Norwegian fjord. So the floor is yours, Lars.
Okay, thank you very much. I guess you can hear me all. So yeah. Thank you for the introduction. I will shortly present this project that is starting up now. Harmful high biomass blooms warning system for, first of all, finfish aquaculture, but we have over this last year also experienced that there are other stakeholders that are in need of this kind of information. At the moment, we are a rather small project group, only consisting of 3 persons, myself, and then I got 2 colleagues with me that is handling data and also the modeling part. So the main goal or objective for this is improve the warning service for harmful high biomass blooms in coastal water in a changing climate. The geographic coverage is quite large. We aim to take out the whole Norwegian coastline. It's a fairly long coastline. But the advice that we give out for industry as well as authority is down on a smaller scale. So the whole coastline is divided into 13 sectors that we use. Yeah, I think you can take the next, please. Thank you. So the high biomass of microalgae could lead to negative events or harmful effects for activity in the coastal water. There could be either fish mortality directly for the farming, or also this oxygen depletion, especially in the field system. And we see that with a changing climate, increase runoff, changing physical condition as well as chemical condition in the fjords. These topics are more and more important for both the authorities giving advice on environmental issues, but also on the fish farming and aquaculture industry. So far, the salmon industry in Norway has experienced big economic loss over the years due to these kind of blooms, both toxic algae, but also the high biomass blooms event that we have. One of the things with these bloom are that they cover a very large area, and they will be transported along the coastline, at least in Norway, due to the coastal current, going in and out of the fjords. So by using only in situ measurement, it's not possible for us to monitor and give advice on this one. So for us, the satellite, the remote sensing, is like the key factor to come on with a better product. So the project aims to use the information that we have from the satellite at the moment, but also try to improve them by looking into details on the algorithm to adapt them to, like river runoff, increase organic loading, yellow substance, and so on. So we hope to combine the satellite in situ and model data in the warning system that we are building up. Next, please. Already we have a web portal running, giving advices to industry and authority. This is only in Norwegian at the moment. Hopefully, or at some point, it will also be translated over to English, but at the moment only Norwegian. At the moment, we had a satellite product up there, but it went down in December last year, and now we're hoping to get up a new product through this project. So the aim here is to collect satellite information, optimize it to what we need, and adapt it to the coastal waters and the fjord systems along the Norwegian coast. We also want to compare the satellite information with in situ data to improve the algorithm, especially for chlorophyll estimates in the fjords. In addition to that, we have an add-on project that we hope to get better integrated with this warning system that we have. It's been 2 projects that has been running for some time, where we use remote sensing data in model to say something about the likelihood or probability of harmful algae blooms. So the remote sensing will be a crucial component in developing this operating system. Next, please. Yes. So the main data will, of course, be the chlorophyll A, and use that as a proxy for the phytoplankton biomass. But as I said, we also want to look on the temperature, salinity, mixed layer depth, organic and inorganic material in water, and also looking forward to see what the hyperspectral data could give us of more information, maybe bringing it down to not only phytoplankton biomass by sense, but also maybe down to phytoplankton groups. That will strengthen the product. Along with this one, there's a lot of in situ data going in from ongoing projects, phytoplankton composition, chlorophyll, radiometers, CDOM, and so on. Data that are already available from ongoing monitoring activity at the Institute of Marine Research. We have selected two, call it pilot area. One is the Skagerrak region that can be seen in the small map up there. And the other one is Hardangerfjorden on the west coast of Norway, just to get this fjord dynamic and river runoff problems into the project. Next, please. Okay. I just want to show we have this year we actually use satellite as one of the primary sources for information, for giving warning for the industry, as well as giving advice for the authorities handling high biomass and blooms. This spring, in March, April, we have a huge bloom of a species called Pseudochattonella. It started on the Danish coast, killed fish there, and was picked up by the satellite. Yeah, I can't point at this one. No. And picked up by the satellite. Then we used the satellite to track the bloom further as it went on. We also had a cruise going on. There's a small map of the Skagerrak here, where we did sampling and where we was able to verify that the Pseudochattonella was a dominating species during this high chlorophyll A measurement from the satellite information. So we know that was a harmful algae. We had a fairly good idea where it was going, and we followed the bloom as it went on in end of the March and into April. We also use dispersal model to say something about the upcoming transport. There's a short picture there showing the drift or spreading of the algae bloom from the Swedish west coast into Norwegian water in the period 1st to the 6th of April. So by using on the satellite, we provide significant information for the warning and also to inform the finfish farm industry on the Norwegian Skagerrak coast about the bloom that was heading against them. Next, please. So we tracked the bloom along the Swedish west coast into Norwegian coastal water. We had some in situ sampling point. We have one fixed one with a blue arrow in the map here that we do regular monitoring, where we observe the cells, we counted them, and we have the concentration of them, and was able to follow it as the front of the bloom hit that monitoring site. We run a new dispersal model. It turns out that the current systems or the current water transport was bringing the bloom out from the coast and into the open Skagerrak. And this was verified by the satellite image the following date in 8th to 12th of April. So for the Norwegian side, there was no observation of fish mortality or behavioral change, and that is a good thing. For us, it was a really good example of how to use the satellite information to track and to give good warning and advices for both the industry as well as the authorities. Next, please. So stakeholders and user engagement for this project. As I said, the high biomass bloom could be a threat for marine life, finfish farm, wild fish, aquaculture industry in general, direct or indirect. We had an ongoing project a couple of years ago that did most of the code development of a web portal where we have a focus on the authority and the fish farm industry. And we managed to get good dialogue, and we still have that with annual meeting where we go through the product that we have and further need of information that they come up with. Two new things that appeared this year was the well boats, also fish transport. They were also suddenly a need for maps of high biomass of blooms. When you're transporting fish, they want to close the boats when they're passing high biomass blooms to reduce the risk of mortality within the boat as they go on. And there was no map available, at least for the Norwegian coast, with high resolution. So that is a new stakeholder coming in. The other one is actually the tourist industry, recreation, that also wanted to have this kind of information up on a web portal. So we're trying to bring them into the project now. I guess maybe next year or something like that. I don't think this year will be possible to get them in. I think that was the last one. Yep. Next should be the last one.
Perfect. Thank you very much, Lars, for the presentation. If you have some question, you can either raise your hand or maybe you can write it directly in the chat, as Anne-Claire just mentioned. I do have a question for you. So you mentioned some other possibilities to extend the product. So do you think it could be also extended in other territories, other countries? Do you think there is some interest? Did you receive some questions from other countries about these problems?
Yeah, I think so. Absolutely. I know already that is an initiative taken in Sweden for similar projects. So then you could add on, so you're covering Skagerrak in a way. I also work for the UNESCO IOC task team of early warning system for harmful algae, working in African country. And I know at least for Namibia, there is absolutely a need of this kind of product. They have huge bloom that starts out in the sea and then is transported into coastal water, causing oxygen depletion, fish and wildlife mortality in the coastline. So yeah, absolutely, there is I don't want to say need, but it's possible to extend it to other area. And also when, like for the Skagerrak region, Sweden, Denmark, Norway already collaborate quite close when it comes to these high biomass blooms that occurs in the Skagerrak. So why not include other countries as well?
There is a question from Selima. Selima, you have the floor.
Yes, nice to have this today. Hello, everyone from Sweden here. Just to confirm that in Sweden, yes, we have the such problem too. And SMHI, which is the Swedish Meteorological and Hydrological Institute, who takes care of this, using also Sentinel-3 data, or C, and validating with their algorithm. And as you know, that not all waters can work well with the same algorithm for detecting the chlorophyll and all this. So my question is, do you have some collaboration, or do you compare some results, your results with SMHI results, to be more sure to have good results in the future for all the Nordic countries? Thank you.
Yes, I have. I know one of the principal scientists behind the new application going in at SMHI, Bengt Karlsson, quite well. We have been working together for a long time. And actually, in the upcoming new Swedish project, I'm sitting in a reference group for the project. So there's a close collaboration there, not only directly between SMI and Institute for Marine Research, but we also work together in ICES and IOC groups. So yes, absolutely. And it's correct, as you say, there will be difference between Norwegian and Swedish water. However, the west coast of Sweden is very similar to the south coast of Norway, so that could be a similarity. But of going into the Baltic Sea with the cyano blooms and so on, there will be something else. And again, I think there's a huge possibility to stretch out and cover larger and several countries in the Baltic Sea as well. Why not?
Thank you.
And we do have a question in the chat from Ambre. You mentioned that your project is used to give advice and warnings, but are such notices binding to those you give them to? For example, are those warned obliged to provide changes, or are they simply informational?
In most cases, it's information, but based on the advice that we give, there are measures that the fish farms could do. So they also use it in their production cycles. So if they know there's a harmful bloom coming up, they can do measures to reduce the negative effects of the bloom. That could be we are not moving fish anymore, but it could be other measures that it is possible to take on the site. Of course, that is something that the industry themselves have to decide on. So what type of measure they want to do, because all measures are cost money as well. They will lose production in a way. So, but I say it's a mix. They don't have to follow what I say, but often they do. It's all depending also on the species. Like this April species, we know it is not only a high biomass, but the species that dominate this year's bloom is also known to have a toxin, an ichthyotoxin that kills fish. And so then they are a little bit more on the alert.
Thank you. And another question from Jennifer. What model do you use for your project?
There are two models we're using. The one is the dispersal model, just to look on transport of the algae. Then we have developed a model here at IMR that is called Nordkyst. We have different resolution of that. It goes from 800 meters grid to down to 30 meter. That goes mainly on the transport and bloom, bloom transport and development. That is the main model that goes into this project. But as I mentioned, we want to continue the work and also include a model developed by Edison Silva at the Nansen Environment and Remote Sensing Center here in Norway that combine climate or environmental data from the satellites with in situ observation of harmful algae. It's not a high biomass bloom. It's more focused on species that causing accumulation of biotoxins in mussel. So it's a little bit on the side, but still we think it's a tool that is good and could be used. And it's like a probability model or likelihood for a bloom. And we hope to give a kind of maybe we could model up to a month ahead into the future. What is the likelihood of a bloom?
Perfect. Thank you very much, Lars, for the presentation. And if there are more questions, you can still ask them in the chat, and we'll, of course, send them to Lars after this meeting. Thank you very much, Lars, again, for your presentation. So for the second project, we are very delighted to welcome Marie Jagaille from the company iTech Imaging, who will present the Littosat project. So just in a few words, the Littosat project is a French project that provides managers of coastal areas and marine protected areas with a dashboard for monitoring the spatial and temporal evolution of coastal vegetation. So Marie, the floor is yours.
Thank you, Alexia, and hello, everybody. I hope you can hear me well.
Yes.
I'm very happy today to present the Littosat project. We are a SME at iTech Imaging, a French SME, and we developed a coastal satellite dashboard. The geographical coverage is for today covering 3 pilot regions in Brittany region, Normandy region, and Gulf of Lion in the Mediterranean Sea in France. The accessibility of the project is partly open source and partly commercial. I will describe it later. And we obtained an accreditation in 2022 for the first project in France, and we just obtained another label this year for an extension of the Littosat dashboard in South Africa. Next slide, please. First of all, I will provide you some context elements of the project. In France, as in all the world, there is a high concentration of the population on the coastal areas. And at the same time, the ecosystem health and management is evaluated. Here are the some figures from a French report of the ecology ministry, showing that a very large proportion of coastal habitats are in unfavorable conditions. The leverage that we have is that almost 1/3 of France's maritime areas are covered by maritime protected areas. So there is also on the other end a lack of knowledge on the foreshore, this area subject to tides, that is still poorly covered by satellite products, which were first developed for the marine areas or the continental areas. So we want to provide tools for the coastal area stakeholders, such as marine protected areas and local and regional authorities in general, by providing a satellite dashboard. Next slide, please. The general objective, as Alexia mentioned, is to provide spatiotemporal monitoring of coastal environment parameters for the manager of coastal areas using new satellite data, mainly Sentinel-2 images, and based on a simple and intuitive web viewer, and also distributing data and geoservices that meets the INSPIRE European directive. The first SCOPE project, which started in 2022 and it was achieved last year, focused on the coastal intertidal vegetation and allow us to distribute automatically produced seasonal mosaics of Sentinel-2 images, to develop an innovative product on submerged intertidal vegetation, and also to build up an early adopter community. Next slide, please. The main data used are the Sentinel-2 images. On the animation, you can see the coverage of the pilot region in Brittany, in France, that is covered by 3 passages of the satellite. And the added value of the mosaics, with here a screenshot of the dashboard, allowing end user to have a homogeneous coverage of the coastal area. The name of the products are Tidal S2, the low tide and high tide mosaics of images at different tide levels, and a vegetation index on the foreshore, EVS2. They are both seasonally updated, and the spatial resolution is 10 meters from Sentinel-2. Next, please. I will now give you a demonstration with a video of the dashboard. So you can see on the homepage of the dashboard the description of the application, allowing to follow and monitor the foreshore vegetation, the differences between 2 seasons, within vegetation index. We also distribute local inventories on vegetation or the bathymetry layers, the national bathymetry layers, and also complementary commercial satellite images such as SWOT or Pleiad. Our data developed in the framework of the SCO, the tidal S2 mosaics and the EVS2 vegetation index are also referenced in a regional geographic information system describing the data and giving the WMS URL. So end user can directly use the data in their GIS. We also added some contextual information about the Natura 200 areas, the natural regional parks, and the marine protected areas that are the end user that we are addressing in this project. On the viewer, you can also see the tidal S2 mosaics at different seasons with a seasonal plugin allowing to show the different seasons. Here, for example, in spring, in winter, and we will focus on an example here in an area in Brittany. You can see here a bay. The triangle here is a bay covered by a Natura 2000 network. And we will see the foreshore between the green line and the blue line. And we will see the different mosaic images, for example, at low tide. And you can see the vegetation cover on the mud flat that is changing between seasons, with a low vegetation cover in winter, and in summer and autumn there is more important vegetation cover. It's not very easy to see it on the image, and we will see later the vegetation index. And you can also see the high tide mosaic showing this area that can be submerged or immerged depending on the tides. The vegetation index is available in the foreshore between the green line and the blue line on the map. And here we can see the evolution of the vegetation indexed over the seasons. The base layer with the tidal S2 mosaic is synchronized with the vegetation index. It provides a first level of information on the evolution of the vegetation. And it's also completed with another product, the difference of the vegetation index between two seasons. You will see it just in a few seconds. Here, the layer show a gain of vegetation cover between departure season. Here we choose the winter, for example, and we go until the autumn, and we see in red a gain of vegetation cover on the mud flat. And we also distribute national inventories. Here we can see that this vegetation cover is in fact a seagrass that is evolving across the seasons. This is a first level of information, and it's really allowed to democratize the access to these images. Next slide, please. As the demonstration is starting again, it's the next slide now. Thank you. We also provide other satellite data in the framework of another project supported by the Copernicus Marine Service. We also provide information on temperature and chlorophyll from the Siemens products, providing global information related to climate change. With these products, end users can have contextual information about the sea surface temperature, for example. And as I show you in the demonstration, national inventories of the French Biodiversity Agency, for example, on seagrass habitats. Next, please. And also another demonstration in order to show the first version of an API allowing to explore a use case. Here we are focusing in an area in Brittany, the pilot region, and we focus on coastal area, and we are going to monitor an invasive species. First of all, we selected a study area with the end user, and automatically we selected all the Sentinel-2 images available. We obtained around 10 images for a period of 1 year without clouds. And we calculated with the same process that for the mosaics, the vegetation index masking water and showing vegetation index on the emerged areas. The use case focused on an invasive species, Spartina. I think that the video froze. Okay, so you can see the vegetation index, and we will focus on an habitat, Spartin, an invasive species of the foreshore. And this is an habitat really monitored by a natural park, and the traditional methodology for the cartography of this habitat is to go on the field with GPS and also to draw polygons with aerial images. Here we can see some documents of the natural park, and we can see the results after this field work and this digitalization on aerial images. They obtained this kind of maps, and this is the polygon that you can see here in the viewer. We calculated for all the patches of this species the vegetation index. First of all, we can see it on the images with an evolution over the year, with high vegetation index in spring. We can see here by clicking on the polygon on the patch, you can see the evolution of the vegetation index. And this early vegetation cover in spring is characteristic of this invasive species that can colonize the mudflat. We also give information about the context for the whole area of interest. We extracted the data from the Siemens services, and you can see with the red line and the purple line the data about the sea surface temperature and the chlorophyll from the Siemens service. Here for the chlorophyll. So this is an example of more specific use case using the same infrastructure, and a big progress of the Littosat project was the automatization of the selection of the images for the mosaics or for these use cases. Next slide, please. The stakeholder and the user engagement was very important all along the first scope project. We conducted workshops with end user, inspired by design thinking with end user, comparing different viewers, different platforms. And we worked with marine protected areas, coastal observatories, natural parks, and also a national institution like the French Agents of Biodiversity, and also laboratories working on coastal habitats. The involvement of end user increased during the project, and it allows to establish a Littosat follow-up group, and it leads to new projects. I'll mention the Coastal Hub project. And today we are starting a new project for the extension of the dashboard at the international level with South Africa. Our focus point in South Africa and our partner is the South African National Space Agency, and we are going to start the new contact in order to work with the local stakeholders, such as marine protected areas, in order to develop and adapt the dashboard in this country for local use cases. Thank you for your attention.
Thank you very much, Marie, for the presentation. So again, if there are some questions, you can ask them, either raise your hand or ask them in the chat. Yeah, Anne-Claire.
Thank you so much for this presentation. I actually have a question. I wanted to know a bit more about the extent to which the end users are actually using the platform. And I'm not only thinking about municipalities or local authorities or national authorities, but also individuals themselves. Like, for instance, when I saw marine protected areas, I was thinking about recreational boaters, potentially to use the platform to see where there is a marine protected area, so they can also avoid this area or something like that. So I would like to know a bit more about the involvement of the end users. Thanks.
Yes, of course. In fact, for now, we have mainly one end user in the Mediterranean that is using the platform in order to, for example, convince stakeholders in decision processes in order to show changes on the coast and show satellite products. And there is also another use that is not directly a use by end users, but more a tool of acculturation for us. I think that the viewer is not yet the operational dashboard. For now, it's a viewer, but the APIs will be really useful, and working with end user, talking about their needs, working with them, being a partner in a project, help us to develop the API offer, the commercial part of the project. The viewer is totally open, and API commercials. And this is the next step for us to have clients and end users really using a dashboard, for example, for the monitoring of the colonization of the foreshore with the species, for the monitoring of the seagrass that could be disappearing in some areas with the pressure. So it's still potential uses, and we are in this transition between the acculturation and the real adoption of the service.
Thank you, Marie. Is there any other question from the audience, or? Again, if you do have some questions, you can still type them in the chat, and we will forward them to Marie after this webinar. Thank you very much, Marie, for your presentation and for the demonstration. So now for our last project presentation, I'm happy to welcome Susanne Kratzer, who is researcher at Stockholm University, to present the SwedCoast Blue Carb project, which is a Swedish-UK project that aims to produce maps of underwater vegetation by combining satellite data, field data, and specialist knowledge. So Susanne, it's up to you.
Okay, thank you very much, and welcome from Stockholm. I'm at the moment at the Swedish National Space Agency, who is funding the Swedish part of the project. My colleague from the UK, Samantha Lavender, who is actually doing the web solution development. She can't participate at the moment because she's in another conference, but she's saying hello. Yeah, so our project is on developing an open source operational tool to evaluate blue carbon in Swedish coastal waters. We can go to the next slide. The project evaluates and executes mapping of blue carbon. So we mean seagrass and macroalgae with blue carbon, and also bottom substrates by combining satellite field data and specialist knowledge. An example of a blue carbon habitat are bladder wrack. So this is the dominant brown algae in Swedish coastal waters, and also eelgrass meadows. So eelgrass is called Zostera marina, and it provides habitats and spawning grounds for fish and are crucial for healthy and self-sustaining fisheries. Fucus vesiculosus usually grows on rocky substrates, while Zostera marina grow on sandy substrates. So even just by looking at the substrates, you can differ between where these different groups might grow. The Baltic Sea is optically dominated by colored dissolved organic matter, which makes the use of remote sensing to map underwater vegetation very challenging. The mapping has proven difficult in shallow marine brackish habitats, as the absorption of light by the water can prevent satellites from precisely seeing what is happening at depth. Next slide, please. So previous research has shown that the uncertainties of satellite retrieval are higher in the Baltic Sea than on the Swedish west coast. And so for the project, we chose several sites to investigate the use of remote sensing data for monitoring submerged vegetation. These sites include Kristineberg Bay, which is in Gullmaren in the Skagerrak, and also Lomma Bay at Öresund in the Kattegat, and so these are on the Swedish west coast. And we also chose one site in southern Kalmar Strait in the Baltic proper, which is optically a bit more complex. The project outputs include peer-reviewed articles and an online decision support tool for coastal managers. We have here quoted the website for the project. Please, next slide. So our approach is to develop an operational tool that's openly accessible, so open source, and is used for processing and visualization of EO-derived products through an interactive platform. The source data we use is currently mostly Sentinel-2 data for baseline mapping, but we also have access to worldview data, which has a much higher resolution. So the workflow is that we use Copernicus Sentinel-3 data to derive water quality information. So, for example, we have algorithms to derive chlorophyll and also to derive Secchi depth, which helps us to define how deep the satellite can actually view into the water body. And we also use EMODNet bathymetry. It has 115 meter spatial resolution, and also data from Delta DTM, which is a digital elevation model. So combining those two, we can define the intertidal range which is not very big in the Baltic Sea. We only have like 50 centimeter range at the west coast and maybe 5 centimeters in the Baltic Sea. But we also have sites in the UK and also in Australia. That's Samantha Lavender has several projects on other sites globally. So we're co-developing this with the other projects. And the input to the atmospheric correction is MARA2 data for aerosols to correct for the atmosphere. And we also use in situ data from the Swedish monitoring repository and additional data from the county board. Next slide, please. So our end-use coordinator is Carlos Paz von Vries from the county and administration in Norrbotten in northern Sweden. He has experience with using satellite and drone data for coastal monitoring and has put us in contact with various end users in Sweden. We have set up collaborations with various algal and seagrass monitoring groups from different universities in Sweden, and they provide monitoring data, local advice, and also send us sample species to derive the spectral signatures in a scanning spectrophotometer. That's what I work with at Stockholm University, to derive the spectral reflectance of different groups. We have presented our results at the Marine Science Days in Kalmar, and had great discussions and also got good feedback from end users, and we got very good contacts also, and we're now also involved in further applications to continue this work. We had just a talk at ESA Living Planets Symposium in Vienna. And also a pitch there and a poster. We've done quite some promotion of the project. Basically, if you have any questions, please ask me. It's basically we're developing this web-based tool at the moment.
Thank you very much, Suzanne, for the presentation. Yeah, if you have any question, again, either send them in the chat or raise your hand. I just had one question about the platform. When do you plan on having the platform published? Do you have any?
Yeah, we're planning for some demonstrations in the autumn. So we haven't decided yet in which format we will demonstrate it. We'll see. We're still very much in the development of the technical solutions. It's very complex because the optical properties of the Baltic are very complex. So you can't just read in some Sentinel-2 data. You have to do some atmospheric correction and also include the information about the digital elevation models and all that. So it's quite complex to set it up.
I see a question from Ambre. Yeah. Is it meant to stay localized to Sweden, or are you hoping for more international users?
Well, this is at the moment we're sort of developing this part as both in Sweden as well as in the UK and Plymouth Sound. So I haven't included this because it's like Samantha Lavender's project where she's working on another project in Plymouth Sound. And she has in parallel also collaboration with CSIRO in Australia. So they have some Australian sites where they're developing the same open source methods in parallel. And they also have some islands in the Pacific where they're testing it. So it's very global.
Okay, so I don't think there is any other question. Thank you again, Suzanne and Selma, for this amazing project. And thank you again for having been present at the ESA Living Planet Symposium. We also had the pleasure to have Samantha Lavender on our SCO Insight session. So it was a pleasure to have the project presented during the ESA Living Planet Symposium.
Yeah,
Thank you,
we were
Susan.
very pleased about that. Thanks.
Well,
And Claire?
I think this closes our first ClimateSCOpe. So we're very happy. So we are very happy that it finally happened. So thank you so much for joining. Thank you for your attention. I have noticed that our participation rate didn't fluctuate from the entire 1 hour and 16 minutes. So thank you so much really for your attention, and we really look forward to see you at the next edition of the ClimateSCOpe, hopefully in October. I think the next thematic will be aligned with the COP30. So we will try to make it on the forestry to be confirmed, but this is a thematic that has been put forward. So thank you so much. Please give us your feedback. Again, you have the QR code here posted on the slide. Please scan it, and the form is really short, so it's not going to take more than 3 minutes of your time. So this is very important for us actually, so that we can prepare the next edition in the best condition and integrate all your comments. If you have any question, please contact the SCO Secretariat. You have the address just here. You also have the address of the Space for Climate Observatory website, where you have all the information about all the SCO project as well. And you will have the recording of this presentation on the YouTube webpage of the Space for Climate Observatory as well. Don't hesitate to follow the SCO online on LinkedIn, and also to subscribe to the SCO newsletter, where you can receive all the news from the SCO. I thank you so much, and wish you a good end of morning, afternoon, or evening, or even night for some of you. So thank you so much, and see you next time in October, and have a very nice summer. Thank you.
Thank you very much.